Alright, this problem here, another gas law problem, and first thing we gotta do is read it. So if a gas has a volume of 555 milliliters at 33 degrees Celsius, what will its temperature be when the volume decreases to 0.475 liters? Alright, so now we're ready to find out what formula we're going to use by figuring out what this problem tells us. So we have a volume of 555 milliliters at a temperature of 30 degrees Celsius. What will its temperature be? Okay, so I'm now looking for a new temperature, so it makes those ones and twos. When its volume decreases to 0.475 liters. Similar to one of the previous videos, if we have volumes, more than one of them, our units have to be the same. Same with pressures. If our pressure, if we had pressure in this and the units weren't the same, then that would lead to some trouble. But before we really do anything, we know we're going to do a gas law problem, so that means Celsius has got to go. So we're going to add 273 to this. That'll bring us up to 293, actually 303. Can't add. 303 Kelvin. And now we have our choice to convert this to liters or this to milliliters. Either divide this one by 1,000 or multiply this one by 1,000. So let's just change liters to milliliters. So we've got 1 liter is the same as 1,000 milliliters. So liters are going to cancel. And that's going to give us 475 liters. Now we're going to find a formula that contains V's and T's. And we've got Boyle's Law, and that's V1. I'm sorry, this is Gay-Lussac. No, Charles' Law. Can't think today. V1 T1 is equal to V2 T2. And I'm looking for T2. So what I'm going to do first to get these fractions out of the way is I'm just going to cross multiply. V1 T2 is equal to V2 T1. All I did was take those two and put them together. And now it's going to be a lot easier to get T2 all by itself. So I'm just going to divide each side by V1. And run out of space over here, so I'll write down what this equals. So I've got V1. Actually, V1 canceled, sorry. T2 is equal to V2 T1 over V1. Now we're ready to plug our numbers in. So T2 is equal to, well, my V2 was 475. I did it again. Milliliters times my T1, which was 303 Kelvin, and my V1 is 555 milliliters. So milliliters are going to cancel. I'm just going to be left with Kelvin, and that is a unit of temperature, so that's a good sign. So what we'll do is just take 475 times 303, and then we're going to divide that answer by 555. And if I do that, I end up with 259 Kelvin. This problem doesn't tell me to convert it, so I can keep it in Kelvin. If I convert it to Celsius, it's not a big deal. I'll just subtract 273 from it. And I think that should give me about negative 14 Celsius. So our volume decreased, which means our temperature would have to decrease. So that's how you do one of these problems.